Welcome to this video. My name is Frederick Mwema. I live in South Africa, the city of Johannesburg, in Gauteng province. And in this video, I want to introduce to you two important concepts of physics, which are forces and free body diagrams. In physics, there are different types of forces, and in this case, I've narrowed them to 6 types of forces. They are what we call the applied forces, the normal forces, the gravitational force, the friction force, the air resistance, and the tension stroke spring forces. Let's consider the applied force. Applied force, these are forces applied by one body to another, and usually the body applying the force is in motion. For instance, consider a footballer kicking a soccer ball. The foot has to be in motion to apply or to exert a force F for this ball to move from this point to that point. Another example is a gymnasium. The man has to exert force on these weights so that he can lift it. For a man pushing a wheelbarrow uphill, he has to exert a force for the wheelbarrow to move the weight in it. And for a demolition of a house, the truck has to exert a force as a result of its motion for it to demolish the house. And therefore we can define an applied force as a force exerted on a body by another body, and usually the body exerting the force is in motion. Secondly, consider the normal force. These forces are usually experienced in bodies mostly in contact and stationary. For instance, for a man seated on a chair, the chair will exert a reaction force to counter the action force exerted by the man on the chair. So both action and reaction forces are normal forces. They act perpendicular to the surfaces or to the areas of the bodies exerting the forces. Another example of such forces can be experienced by a book placed on a table. The table exerts a reaction force to the action force of the book, and as such, the table is able to maintain or to take the weight of the book. For a bridge, the cars flowing over a bridge, they exert an action force to the bridge. The bridge has to counter the force by acting a reaction normal force, and as such the bridge is able to maintain or to take the weight of the car. Another example is the bridge. A bridge is supported by columns, and these columns exert reaction force to the action of the bridge, and as such the bridge is able to stay intact. Another case is a loaded truck. The truck body has to exert a reaction force to the weight of the load, and as such the truck is able to take the action force of the load. And usually action and reaction forces acting on contact bodies, and usually the stationary bodies, are what we call the normal forces. And mostly the reaction and action forces must be equal for the supporting body not to crash. If the action force is more than the reaction force, then the supporting body will not be able to take the action force. For instance, if the weight of the cargo on the track of the body is more than the reaction force the body can offer, then the truck body will crash. The other common force is the force of gravity, and this is defined as the force exerted on objects by Earth or Moon or by other large bodies, and mostly this is usually the weight of an object. It is the force of gravity which pulls everything downwards to the ground. The examples are illustrated: a fruit falling from a tree, and so forth. The other type of force is the friction force. Friction force, these are forces which are as a result of two bodies under relative motion. For instance, for a man pulling a box on a floor, the floor will exert a resisting force F to the motion of the box. Another example is a car on the road, on a rough road. There is friction force between the tire and the road, and the friction force will act opposite to the direction of the motion. For athletes on the track, there are friction forces between their shoes and the road, and these friction forces are the ones which make athletes to have the grip on the road such that they do not slip and fall. And forces exerted by a surface to resist another motion moving across it, it's how we define the friction force, and it usually acts in the opposite direction of motion. Another example of friction force is inside the engine. Usually the piston reciprocates, it experiences upward and downward motion within the cylinder bores. There is a contact between the stationary bore and the piston. There is a friction force. There are friction forces between the cylinder bore and the piston, and with time the cylinder bore wears out, and that's why maintenance is required for an engine. In a car braking system, the contact between the pads and the discs has a friction force which enables the braking system to work. Another type of force is air resistance. This is just like a friction force, but is as a result of air. For bodies in motion, like an aircraft in air, will experience a force against its motion, and this force is what we call the air resistance, is a friction force in air. The same forces can be experienced by a moving ball in air, or birds moving in air, and so forth. The other type of force is what we call the tension forces. Tension force is transmitted through wires, ropes, or cables when they are pulled, and this force usually occurs in an opposite direction. For instance, for this pulley system, the rope will be pulled downwards as a result of this support, and there will be a resulting force against the pull for the rope to sustain or to support the load, and this type of force is what we're calling the tension force, and the tension force always acts in the opposite direction to the pull. In this case, for the winch to pull a load, a wire cable is needed, and this cable will be under tension in the direction opposite to the pull for it to work. And mostly the resisting force, or the body being pulled, must exert a lesser force to the tension force for the pulling to occur, or for the motion of the body to occur. For these conservationists trying to contain a baby elephant, they have to tie it around with ropes, and those ropes must be under tension for them to overcome the strength of the animal. For a suspended bridge over an ocean or a water body, the wire cables will usually be under tension due to the weight of the bridge, and the tension force should be able to take the weight of the bridge for it not to collapse. The forces act opposite the direction of pull. It is important to note that. The last type of force is the spring force. Spring force are experienced when springs are stretched or compressed, and the force will usually act against the direction of the loading or the direction of motion. And this is experienced in automotive suspension system, and the forces will always act to counter the stretching or the compression, deflection of the spring. Now, the next thing is the free body diagrams. Free body diagrams are used during force analysis to show the relative magnitude of forces and their directions. For instance, if we consider this complex system of a pickup moving up a small hill, how do you analyze this system? Using the concepts of forces, you have to draw a free body diagram. A free body diagram is just a sketch of line works, as a line work sketch of the actual system. In this case, the body, the red box represents our pickup, and the inclined plane with angle theta represents the hill. The horizontal represents the imaginary horizontal ground, while the inclined angle theta represents the hill. In this case, we expect an applied force as a result of the motion of the pickup. There is a friction force countering the motion of the tire against the road, and there is the weight of the pickup, and of course there is a normal force or a reaction force as a result of the heel onto the body, and this force is what keeps or maintains the pickup onto the ground. Another example is a man climbing a cliff with a rope. So there will be forces due to the pull of gravity. The man will be pushing on the cliff, and there will be pull of the reef, the pull of the rope, and these forces can be represented as such. There are so many examples of free body diagrams. Another example would be a suspended bridge. In a suspended bridge, you would consider the supports where the bridge is supported by the columns. You would also consider the force, the force of gravity or the weight of the bridge. You should also consider the tension forces of the rope suspending the bridge, and also the compression forces of the bridge. In summary, for you to draw a free body diagram, you need to know the types of forces acting on the body, and for you to know the types of forces, you need to first understand what the different types of forces we have. Is it an applied force? Is it a normal force? Is it a tension or a spring force, and so forth? Then the next thing is to determine the direction of those forces. And then finally, you determine the quantity of the forces. Okay, and one thing to mention is in free body diagrams, sorry, if we can go back, free body diagram, the arrows will indicate the direction and the magnitude of the forces. So the larger the magnitude of a force, the longer the arrow. And the arrow direction shows the direction of that force. It's important to note that. So, you must first determine the type of the force and the direction, and then you determine the magnitude of the force. And usually in most physics problems, the magnitude of force will be provided. Thank you very much. That's the end of my video. And I would like to say that in my classes, I usually have question and answer session at the end of the class. It is important to note that those who ask questions will receive a candy. Each question earns you a candy. It is called Candy for Learning. Thank you very much, and always be punctual for my classes. Goodbye.